Okay, in the previous video, we spoke of a linked list that is of this type. So I'm just going to be putting it on the corner here so that we can work on the part of how we can implement uh, um, this linked list in different ways, yeah? So we had the data element here, we had the pointer here. So we had 5 elements. There were 6 in actual fact. 1, 2, 3, 4, 5, and another one. We had six nodes. The first one was A, the second one was a C, then we had a B, then we had a D. And this was empty, but it was pointing to number 5, and this was pointing to nothing. Oh, this was pointing to nothing. This was -1. This was pointing to -1. A was pointing to number 2. Number 2 was pointing to number 1. Number 1 was pointing to number 3. So this is 0, 1, 2, 3, 4, and 5. These are index positions, yeah? We already know them because we always have them by default in Python, yeah? Then we said that the start pointer, we said it was equal to 0, where the linked list is starting in. Then we had a free pointer. A free pointer came through with the value 4. Then my now pointer, this was -1, I meant to say. My now pointer was equal to -1, something like that. So with this now having been said, we can now go ahead and implement this. We said we can implement it in 1D arrays, 2D arrays, or even in using a record. So I'll first implement this using a 1D array. And I said you can just call the array linked list like this. And it's going to be having two 1D arrays. The first one will contain the data elements. So in this case, I have data. The first one is A. The second one is a C. The third one, let me just put them all in caps here. Second one is a C. The third one is a B. The fourth one is a D, like that. Then I have a none because there is nothing on that, so I'm just going to put in none and none because there is nothing on that here. Then I have also the pointers part. So I'm just going to be creating linked list pointers like this. Then I'll be like, or can I just call them pointers? It's okay. Okay, that's okay. Then I have a 2 on the first position. I have a 3. I have a 1. I have a -1. I have 5. Then I also have a -1. That's how I can implement this. Come on, I had a -1 here. That's how I can implement my my linked list. Come on. Oh, it's supposed to be equal sign here. Like that. Then I need also to indicate the pointers, that the start pointer I need to be initializing them. The start pointer is given a 0. Oh, come on, it's 0. Then we also have a free pointer. The free pointer is given is 4. Then we also have a now pointer. And now pointer is given as -1. So this, what I have here, is the implementation of this thing that I've created here. You understand even better when we write a code that's going to be displaying all these elements in their order. But right now you can see that what we have done makes sense using this logic. We said this is the first element. It is 1 and 2. It is A and 2. There's A in the first one, 2 in the second one. C and 3 in the data is C, and the pointer is 3. The third one, we had B and -1, so the data is B, the pointer is 1. That's how you can trace through to see if it's correct or not. Yeah. So that's basically what we have is if we want to implement this in 1D arrays. So I'll close that up. Then we go now to the part where we do an implementation using a 2D array. When you're using a 2D array, as I said before, an array is a data structure that allows the implementation of data or to record data elements that have the same data type. Python will allow you to use lists, and lists can take even arrays, that it can take elements that have different data types. But arrays, they need these to be actually coming through as the data in the pointer to be of the same data type. So I'll just implement using Python lists because they allow me to use that, and so that I can show you how it will be looking like. So my linked list is going to be coming through like this. My first element is going to be my first element is going to be an array with a and 2 like this. And the second element is going to be again an array that is going to be containing C and 3. Right. My next element is going to be again an array that is containing B and 1. Oh, come on. B and 1 like this. My next element is going to be an array that is containing D and D has got a -1. Then the next element is going to be a none that is with a none that has a 5. Then the last element now is gonna be again a none, but that has got, oh come on, that's supposed to be in an array, which makes it 2D. It's gonna be that, yes, but the none is supposed to be containing a -1. That's basically what we have. That's how you can implement this using 2D arrays, and your guess is as good as mine. We're still gonna be going ahead to say what? To say to just put in the same thing like this. If we have the start pointer is going to be coming through as my 0, my free pointer is going to be position number 4, my null pointer is supposed to be equal to -1. That's basically how the data is supposed to be looking like when I implement using 2D arrays. As I said, you understand this even better when we start to do the part of how we can traverse through. But basically, that's how the code is supposed to be looking like. Yeah. Then my favorite part now is the implementation of this using record, right? Using a record. So when you're using a record, you gotta use a class in it, yeah? So my class is gonna be equal to what? My class will be called a node, so that each and every element, you can check through the pseudocode that I put in the first video. But my class is going to be called a node that's going to be containing, oh sorry for that, I just went on to run, yet I did not give initial values. So that's going to be containing, we have data and a pointer. So I need to initialize those guys. So if you have done object-oriented programming, you understand that I'm just going to be creating a constructor here, def __ init __, then I actually give in my data elements that I need. First of all, I'll start with self, then I put in my data, then I also need a pointer. That's basically what I need. So with that now, I'll then go ahead and say data, oh actually it's yeah, I'll not make them private, so I'll just put them as public. That's data, matter of fact itself dot data is equal to the data element that I took as a parameter. Then again self dot pointer is gonna be equal to the pointer that I took again as a parameter. That's all that I need to do. So now I just created a class and its attributes. So what I need to do now is to create a linked list now. My linked list, I'm just going to be giving it another name like this, linked list, supposed to be containing now a 1D. This is now out of the class, you see that? My linked list is going to be containing a 1D array, but each element is going to be of type node. So it's node, I have an A and a 2, like this. That's going to be my first element, like this, right? Second element is going to be again a type of node of my node supposed to be containing. Now I'll put this part, that's going to be C and that. Then I'm going to be having again another node, so I can just say, I can just put all the nodes all together here, so that I don't need to keep on doing the same thing over and over again. So I'm going to be having node there, I copy that and I put a comma, I paste another node, comma, another node, comma, another node, comma, and another node. I think so. So I need this guy will come to be here, this guy will come to be here, then the none and the 5 will come through to the element of this guy, and the none and the -1 will come through to be elements of this guy. So I didn't need this, definitely. I didn't need this. So that's how I was going to be doing my implementation. Let me just see if I can actually minimize this. Yep, I can. So that's basically how I was supposed to be doing my implementation using a record. I have a linked list that contains each and every element being a node, and I also need to bring these guys again to be used again here. So my why is this giving me an error? What didn't I close? No close in bracket. All right. Okay, where is that? I opened here and I closed there, so this guy is not supposed to be here. Beautiful. So we have this now. My null pointer is still -1. My 4 element position number 4 is still my empty node. Then my 0 is still my start node. That's basically how I will do the implementation when I am using a 2D array. When I'm using a record or when I'm making use of a class. So this will be its own node. 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 That's basically what we'll be just trying to do when we are implementing using classes. That's pretty much how we implement. That's pretty much how we implement these guys. I don't know if there is any question, but this is basically the implementation. So if I run that, you see, okay, I'm seeing no error there. So if I want to see the data that is on position number 1, matter of fact, let's not worry about that. We'll just do that as far as traversal is concerned. I'll just build on from this code. I just wanted you to know the different types of implementations of linked lists. You can implement using classes. You can a class in an array, a 1D array. You can implement using 2D arrays, that is if they're of the same data type, and you can implement using 2 different 1D arrays if the data types are different. That's basically how you can do the implementation. I hope that makes sense. Let's see how we can do the traversal when we move on to the next video.